Welcome back to the second part of our video lesson on simplifying trigonometric expressions with the fundamental identities. For this portion, we're going to be focusing on the Pythagorean identities, and I wanted to start by explaining where these three identities come from. And so they're actually derived from the Pythagorean theorem. And as you can see, I've got this picture. It's the first quadrant of the unit circle, basically. And we know that every coordinate is x comma y, where x is your horizontal distance and y is your vertical distance. So in this problem, the angle is going to be called t instead of theta, which is why you see t's in our formulas down below. This here is x, and this is y. And so to make the Pythagorean theorem, the Pythagorean identities make sense, let's start with the Pythagorean theorem on this triangle. We're going to start with a squared b squared equals c squared. And we're going to replace it with the legs and hypotenuse in our specific triangle, which is x squared plus y squared equals 1 squared, or just 1. Now we turn it into trig. So let me switch colors. And let's talk trigonometry. We know sine, we know cosine, and we know tangent. So let's write an expression for each of those. Sine t on this image is the opposite over the hypotenuse, or y over 1. That means that y equals sine t. Cosine is adjacent over hypotenuse, which in this problem means x over 1, and that means x is equal to, that's an x, cosine t. And finally, tangent is opposite over hypotenuse, which in this example is y over x. And we are not going to simplify that expression any further. From here, we've got our expression that says x squared plus y squared equals 1, and we can now substitute our trig expressions here. So we've got blank squared plus blank squared equals 1. And we are going to replace the x with cosine, and the y value with sine. And you can tell in this expression it's been rearranged to say sine squared first, but it is really either cosine squared, sine squared, doesn't matter. And so you can see sine squared plus cosine squared equals 1. And from here, these two are just variations on the original. And I'm going to use two different colors to explain this to you. So imagine if you took the original Pythagorean theorem and divided everything by cosine squared. How would each term in the equation simplify? Well, sine squared over cosine squared is tangent. Cosine squared over cosine squared is 1. And 1 over cosine squared is secant squared. So the same thing happens over here, except we're going to divide by sine squared instead of divided by cosine squared. So what this means is that these three trig expressions are really all the same relationship. They're all the same concept, just using different trig expressions. What we're looking for when we're simplifying is matching and replacing different components of these equations into our expressions. So let's take a look at the first one. Very straightforward. For example 1, we have sine squared plus cosine squared, which is exactly this identity, this first identity right here. So sine squared plus cosine squared, sine squared plus cosine squared means that we can just say equals 1. And then 1 over cosine, we know from above, or from the previous video, is secant squared. And so this can be our final answer. We could actually keep going. We know that secant squared is equal to tangent squared plus 1, but generally speaking, if you can get it down to a single term, that's going to be your simplest form. Next example, we have simplified the expression tangent squared minus secant squared. We have two routes that we can take with this problem. We can isolate tangent squared by subtracting 1, And then we would know that tangent squared is equal to secant squared minus 1. Or we can just look at the other side of this expression. We can see here that secant squared and secant squared is just tangent squared plus 1. So that's the substitution we're going to make in this problem, but keep in mind there's multiple ways to do a single trig expression. Tangent squared theta minus, make sure you're using parentheses, tan squared theta plus 1. Distribute. We get tangent squared theta minus tangent squared theta minus 1. Well, tangent squared minus tangent squared is 0, and so we find out that this entire expression is just equal to -1. Last example. We've got a fraction going on, and it's fairly complicated. We are going to start by converting everything into terms of sine and cosine. So we'll start with tangent t. Tangent is sine over cosine. And in our denominator, secant can be written as 1 over cosine. And cosine, well, that's just cosine. So one strategy that we're going to deal with, especially when we have the addition and subtraction of fractions, is trying to achieve a common denominator. Looking here at the bottom, I can see that I've got 1 over cosine minus cosine over 1. All numbers by default can be written as over 1. So now we need to multiply this second fraction by cosine over cosine so that it has a common denominator. That's going to turn this expression into sine over cosine over 1 over cosine minus cosine squared over cosine. Combine those two fractions there in the denominator to a single expression. One minus cosine squared t over cosine. And then we're going to go back to that strategy that we introduced in the first video. When you're dealing with complex fractions, dividing by a fraction is the same as flipping and multiplying by the reciprocal. So this expression is going to become, make sure I can fit it in my window, sine t over cosine t times, now don't forget to flip, cosine t over 1 minus cosine squared t. Now pause here, because the flip and multiply by the reciprocal only works if the denominator is a single fraction. And I'm going to circle that right here. This one we can reciprocal. If you've still got two fractions like we have over here, you're not ready to flip and multiply. And we want to make sure that we're doing these steps in an algebraically appropriate order. From here, where I've left off, you can see that the cosines are going to cancel. And you might also know 1 minus cosine squared can be replaced with the Pythagorean identity. Let's scroll up to the top. Sine squared plus cosine squared equals 1 is just one version of the Pythagorean identity that we can use. In our problem, we saw that we had 1 minus cosine squared. Well, that's also got to trigger a Pythagorean identity in your mind, because if we just subtract the cosine squared to both sides, we can see that 1 minus cosine squared is equal to sine squared. And that's the replacement we're going to use down here in this example. This 1 minus cosine squared can be rewritten as sine squared. Getting closer to the end, we're down to one term, although it is still a fraction that can be simplified. We're going to cancel out one of these signs, one in the numerator and one in the denominator. That's going to leave us a placeholder of 1 divided by sine t. And if you think about your fundamental identities, 1 over sine t is equal to cosecant t. So this concludes the video notes for our first online lesson, Lesson 12, Simplifying Trig Expressions Using Fundamental Identities. Thanks for watching.